In this demonstration, I'm going to implement Newton Raphson method, which is an iterative scheme to get the roots of a function. And I'm going to utilize a simple function, which is uh, f of x equals x minus cos of x. So for this function, I'm going to calculate the root. Okay. In the Newton Raphson's algorithm, the iterative equation is that a new value of the improved approximation I plus 1 is equal to the old approximation minus the function evaluated at the old approximation divided by the derivative computed at the same point. So this is the equation for Newton Raphson method. So let's set this cell for iteration numbers. And in one iteration, I will start with an old approximation. I will compute the function value at x old. I will compute f prime at the old value, x value. Then a new value will be computed. And to see the convergence of the method, I will compute the error. So a simple straightforward algorithm. So iterations from, we'll start from the first iteration and the second iteration, because in these cells, we are going to do the calculations. So for this problem, x old, let's say 0.5. F of x old is equal to x minus cos of x. Please do remember that all the trigonometric functions in Microsoft Excel and all programming languages, they have default operation with radian measure. So the number you provide as the guess should be interpreted as radian numbers. So this is the function calculation. Then f prime. So f prime of x. So it seems it is 1 plus sine of x. So I compute it 1 plus the sine function of x. This is fine. Then the new value from Newton Raphson method will be equal to the old value minus the function value computed divided by the derivative of it. Right. So a new value has been computed, and let's compute the error as absolute of a new value minus the old value. Okay, so error is there. The next step is to update the approximation. Use the new value at the position of old value and repeat the calculation. So I set this value from, I get this value from here, from this cell, and then perform the calculation. So I can compute the derivative and the function value here, and then the new value will be calculated, the next iteration, and then the error calculation. And then I have to repeat that one for the next iterations. And here we go. Behold, the solution has been achieved. It has been reached. So the promise of Newton Raphson method, that if you change the initial approximation, still it will converge. Well, it converged in 4 iterations, much faster than the fixed point iteration algorithm, and with no requirements on the function definitions. So let's set that to minus 0.5. So still the solution is the 0.7391. If I give it -10, a bit vague guess. So it asks for further iterations to be calculated. Even if we see it here, let's see. Okay, so it is diverging. So not something very much short. So you have to select the initial guess very nicely. Let me check 10. 10 is also a vague guess. So for 10, it seems it is going towards the solution. Yes, it has approached the solution. The last one. Oh, it was even vague, more vague than the 10, but at this one, it has approached to the solution. So computer facilitates you to test the algorithms beyond the reasonable limits even. So the Newton Raphson method can be programmed in Microsoft Excel and can also in any other programming language. So the first part of interpretation, the demonstration has been completed. Take a deep breath. It calms the mind.